free energy now.
Imagine a world in which each home has its own power generator that obtains its energy in such a way that no fuel has to be added. Imagine every vehicle being able to run without ever stopping for fuel. Imagine each appliance having its own power source that never has to be recharged. That is the world of the future. Join with us now as we track our progress towards such a world.
Welcome to the show. I'm your host, Sterling Allan. You can find us online at freeenergynow.net, where you can find a list of past guests and download those interviews. Today, April 25th, 2014, we are joined by Jackob Aganyan, who is with Solar Hydrogen Trends, a company in California that has an amazing super-duper hydrogen production technology using solar and many other modalities. We're going to find out what it is, how it works, and where they're at in the process of rolling this thing out, if they're licensing and all those kinds of business questions along with the technical questions. Jackob, welcome to the show.
Yes, hello, and just a little correction, my last name is Aganyan.
Ah.
Yes.
You don't expect an American to know that, do you?
Well, I'm an Armenian descent, so I have an Armenian last name. Again, Aganov is just, I came up with that last name so that not a lot of people would try to get in touch with me, especially on Skype. So I have to keep it kind of secret.
Well, now it's not secret anymore. And we also have Mike Waters on the line with us. He's the current president of the New Energy Systems Trust, or NEST. Website is energynest.org. And he has a lot of interest in this technology as well, and we'll be chiming in with additional questions that I might overlook, or to dig deeper in the how does this thing work series of questions. So, Jackob, tell us about this technology. There's like 16 different modalities or mechanism at play in getting like a 400 to 1 efficiency scenario.
Yes. So what we have is 16 physical and chemical processes that occur simultaneously within the reactor. And I can name few. We have electrolysis, we have oxidation, catalysis, we have ionization, we have infrasound, sound, ultrasound, hypersound, we have hydrodynamic cavitation, we have electromagnetic field, we have a shock wave, turbulence, I can name few, so we have lots of it.
You also have some cold fusion going on, I understand.
Well, I would be really careful using the word cold fusion. Is for scientists to determine what is it exactly, but what I can assure you is that we have a real low energy nuclear reaction.
When we talk about LENR, we're not talking about a low amount of output, but that a low amount of energy is required to get it to take place in the first place.
Well, the reason we're saying it's low energy actually because, of course, the temperature, you have to pay attention to the temperature, that what is happening. If we're talking about 50 or 60 centigrade, how would you else describe it if it's not a low energy nuclear reaction? If it's only, let's say, 60 centigrade, and you have fission and fusion together combined.
Wow.
Yeah, if somebody can tell me it's not a low energy nuclear reaction, then I would like to know what it is.
Are you getting radioactive elements or radiation coming off of it?
Not really, no.
Now, do you have a diagram somewhere on your website that kind of shows a forced view of these different systems and how they interact?
We don't have that because we still consider the proprietary, and that's why we're not disclosing much the steps of all those processes that take place simultaneously. That's why we call it a symphony, and our latest hydrogen reactor, we call it Symphony 7A, because we have 6 other previous models that we've been working for the last 5 years.
And so your first prototype was built 5 years ago.
Yes, exactly.
You called that one?
That was, exactly. That was product 1, then the second model came up, the third, the fourth, and it was really interesting time when we knew we're on something, but the idea of hydrogen, actually, we were working on something else. This is an accidental discovery. And we've been working and developing methods to recover and extract precious metals from Mother Nature. So this is an accidental discovery. And again, we were using hydrometallurgical and pyrometallurgical methods when we came across with this huge amounts of production of hydrogen. And we didn't know what it was in the beginning, of course. So when we knew that we have this huge amounts of hydrogen, then that was a very interesting subject to us, and we moved from precious metals to hydrogen.
How long ago was that switch?
That was about 5-6 years ago.
And that's when Symphony 1 came out?
Yes. Well, we wouldn't call it Symphony 5 because there was only a few processes that we were combining together. So that would have been a simple electrolysis with perhaps with heat and additional cavitation processes included. So that would probably include either 2 or 3 methods combined together. So it took us some time to elevate and bring all these additional methods and processes, to be added, which at the end we had 16 processes combined together. And of course, the most important fact that we're only using the input of energy is only 500 watts of energy.
And you're getting 400 times that out?
Yes, whatever the results are, it's equivalent of 221 kilowatts hour, which is, I believe, it's about either 440 or 450 times more, approximately.
Didn't you recently do some third-party testing?
Yes, we had a third-party testing. It's a reputable company here in California, and it's a nationwide company that does these tests for big companies, for big oil companies. So they do tests for, big companies. All the oil companies that you can name.
Were they measuring the entire system, the Symphony 7?
Well, their job was to basically, take the flow rate of the gas mass, and including to that, they were taking quantitative and qualitative analysis. So there were also a second company involved, which is also one of the most reputable companies in the world. It's the laboratory that does the qualitative and qualitative analysis. There's 2 companies actually involved.
So they're basically ascertaining the quality of the hydrogen gas coming out on the output side, right?
Yes, but also in addition to that, since we're talking about qualitative and quantitative, also the other compositions, nitrogen, for instance, oxygen.
But that's not really an energy equation in terms of input versus output and energy efficiency test.
You're right. Yes, you're absolutely right. But of course, the purity of hydrogen was 93. The average number came up. We had 3 tests taken. The average number came up to 93.1% purity of hydrogen, and with 50 CFM, that translates to 1,318 liters of pure hydrogen a minute. So that's almost 80,000 liters of hydrogen per hour, which translates to almost 2 million liters of hydrogen in 24 hours time frame. And again, you also have to take into consideration that 2.8 watts of 1 liter of hydrogen is equivalent of 2.8 watts of energy. So you do the math. So if we have 1,318 liters of pure hydrogen, and 1 liter equals to 2.18 watt of energy, so that's about 221.5 kilowatts of energy per hour. The output is equivalent, of course.
And that was with a 400 watt input?
500 watt input.
500. And did they measure that and document that in their testing?
Yes. As a matter of fact, we have a 28-page report completed, and what you see on our website, it is only the cover page of that report that basically indicates, the flow rate, the moisture content, the temperature, the purity of hydrogen, other compositions such as oxygen, nitrogen, DC voltage, DC current, the basic stuff. But of course, in addition to that, we have 27 other pages of a complete breakdown of how it's been done, what has been taken, how it's been measured, and under which conditions, basically.
Is that available to people under NDA?
Yes. Yes, it is. And we're providing to, whoever is interested, of course, that's what we do.
We'd like to come back later to probe, if we can, into those 16 different components and get as much information as we can. Obviously, you've got some proprietary stuff that you don't want to get into, and that's fine, but we have a very curious audience, and I'm curious myself, just to kind of know how you're doing what you're doing, at least to get some kind of idea. But let's now go into the question of the business elements of your company. Where are you at in terms of the timeline of getting this out into a product that people can buy and implement and produce stuff?
Well, of course, we're at the stage that we're looking for a funding to have a manufacturing facility where we can manufacture our hydrogen reactors. So we believe the technology is complete, and the next stage would be to commercialize and to have some kind of a manufacturing facility where we can manufacture at least 300 to 400 units on a monthly basis. And that is our goal. Again, that is our this is how we envision this. But of course, that would require lots of funding, and this is what we're after. And we'll see how it works out. But we also understand, besides, there are also some people interested with integration, because we also understand there are lots of companies out there where they have this ready technology with fuel cells, for instance, but they don't have the fuel source to connect with. And our technology perfectly fits in, so that we can bring and integrate these technologies together, whether it's a hydrogen engine, because there are also some companies claiming to have a complete hydrogen engines ready, so that basically it can use hydrogen as a fuel source. That will be also a perfect match to integrate both of these technologies together. There's lots of interesting segments where this hydrogen reactor can be used.
With that much over unity, 400 to 450 times over unity, it would seem like you'd be able to self-loop so that the output hydrogen is able to power a generator, a genset that produces the electricity that you need on the front end.
Yes, you're absolutely right. And of course, again, we're at the stage that basically what we did, actually, we have developed the fuel source. You have to understand what we have in our hands is we have developed a fuel source that has never been available before. So we are creating a new commodity that was never available before. I understand it sounds probably kind of mind-boggling, but it is in fact actually the results. We cannot go against the results. We have this test results by a reputable company.
And when you say fuel source, you're saying that this over unity aspect turns it into a generator of energy.
Exactly. So it's a fuel source because with the methodology that we have, we can produce hydrogen in unlimited amounts. We really mean that, in unlimited amounts. So basically, if somebody wants 10,000 liters a minute, we can do that. If somebody wants 20,000 liters a minute, we can do that because our technology is scalable.
Before we get too far away from what you were talking about just a few minutes ago, you were saying that you're looking for some investment funds. Do you mind telling us how much you're looking for to build the manufacturing?
I would, I'm not sure whether I should go into details, but it's quite a bit actually, because of course we need a facility. I can tell you what we're looking for. We need a facility probably around 70,000 square feet or 80,000 square feet, and of employees of 150 or 200 employees to build 400 units on a monthly basis. In addition to that, we need all the necessary laboratory settings, including all the necessary machines that will help us to produce all these 400 units. So,
what do you have by way of working systems right now that people who are looking at coming in working with you can inspect and witness in operation?
We're saying, the interesting part actually, we get lots of phone calls, lots of questions, and we tell everyone that you are welcome to come and test the equipment. And of course, it has to be somebody that comes, that they know what they're doing with this technology. Not just anybody that wants to come and test, for 5 or 10 minutes. We need serious people that have interest in this technology. So we're welcoming them to come and test it.
What would you envision a test to entail in terms of the amount of time and the kind of equipment and input versus output that they would be measuring? let's say, for example, that Mike and I were going to come visit you and measure your equipment.
Mm-hmm.
What would the test entail?
Mm-hmm.
How long would it last?
Mm-hmm.
And what would we be measuring on the input side and on the output side?
Yeah, well, we figured it should at least last at least for a couple of hours at least. And you have to understand there's only so much we can do with this hydrogen reactor that we have. Of course, you can measure the input of energy. You can perhaps even, calibrate or whatever you want to call it before the initial test starts, and you can also measure the flow of the gas mass, including you can take the samples and do the quantitative and qualitative analysis of the gas mass. You can do all of that, but of course, to disclose the details of what's inside of it, there is only so much we can talk about it, because of the proprietary stuff that we have.
Yeah, I'm not talking about this test entailing describing what's going on the inside. All we're doing is we're measuring how much energy it's consuming and how much gas is being generated.
You can have a $5,000 or $10,000 electronic equipment that with the margin of error less than 1% can be connected to the exhaust pipe, for instance, and do all the measurements, the flow rate. So these are the companies, the company we've dealt with, they have this expensive equipment because, they only do measurements. That's all they do. They've been doing it for the last 25 years. They're experts in their field. And of course, I'd rather deal with somebody that knows what they're doing than just guessing. Yeah, any electronic device actually would do that. Anything above $700-800 should be able to measure the flow rate.
Okay, so you want to build a manufacturing plant. When we talk about manufacturing, that means that you've got a production prototype, something that has been tested and refined to the point that you're ready to hit the copy button and you're satisfied that it's going to make customers happy. Do you indeed have right now a production prototype?
The production prototype is complete. Of course, it will be needing a little bit of tweaking, basically, to make the automation part a little better. That's the, I wouldn't call it the missing part, but of course it would require a better automation, which of course when the car is built, someone builds the tire, somebody builds the spindle, and somebody builds the body of the car. So we would definitely need to work on the automation process, so that might take for another couple of months perhaps.
So once you get your plant, there's going to be 2 months of engineering required to come up with your final production prototype. But my understanding is once you are making something to throw out into the market, you need to go through UL certifications, and they basically have to certify that the unit that you are selling to customers passes all their safety and other specifications. So you're looking at a several-month process to go through that before you can start selling these things. What are your plans in terms of getting UL or other types of certifications?
Well, of course, the certification must be in place, and we definitely know about it. And just like you said, it could take literally months, before we reach to that point. Not to mention even building a manufacturing facility and or making modifications to the existing facility could take literally months, because we need the state and federal regulations, the local building and safety. If you take all that into account, it could take literally 6 to 9 months just to build a manufacturing facility.
Are you entertaining licensing of manufacturing elsewhere in the world?
Not at this stage, unless we get some people that would be interested in. We can talk about it. All possibilities are open. We are ready to discuss that with potential investors. And again, sky's the limit. Of course, I would be very careful to go overseas right from the beginning. I would rather deal here in the United States, where the technology is protected, and we have, we're protected because the proprietary. We have very interesting proprietary secrets that we would not, we don't want to share with others. So we have to be real careful with whom we're dealing here.
So you would prefer, at least for now, to keep the manufacturing in-house, to keep the trade secrets protected, and then distribute have distribution licenses worldwide from the U.S. manufacturing facility.
Yeah, that should be one of the options again. Again, all options are available, but of course, it depends, how the investor approaches us.
So obviously, if you're going to deal with somebody who wants to actually manufacture and you're going to be disclosing your proprietary secrets, it needs to be somebody that you can trust.
You're absolutely right. But of course, with a project of this magnitude, one has to understand, since we're talking about a new commodity on the market, because our technology offers a unlimited amounts of production of hydrogen. So this is becoming a new commodity on the market. We have to be really careful with whom we're dealing. And of course, we think that the exit strategy is some kind of a consortium of governments to be involved and to protect this technology and distribute perhaps even, by segments slowly, because with such technology, with a quick release, there could be a market crash. So we also understand that part. So exit strategy, we think that with a consortium, just like once upon a time Airbus did, the European company, there were 5-6 governments involved. And we think the exit strategy would be best suited for a consortium. Again, this is my personal opinion.
Would part of the money that you would be receiving from investment up front for the manufacturing facility also go into intellectual property protection worldwide, like a PCT filing?
Yes, definitely, because we definitely need 6, 7, 8 patents to patent this whole thing. And there's lots of interesting stuff. This is a real breakthrough.
Let's take an example application. Automobile, you've got hydrogen technologies where people can run vehicles. I drove in a vehicle that ran on hydrogen or natural gas. It could run in any combination of those gases. And we did a road trip from Salt Lake City to Atlanta, Georgia. And we were able to go that whole distance using gasoline only for about 30 miles of the trip, because there weren't any filling stations available either. He would use liquid, he used biodiesel, or he could use the gaseous natural gas or hydrogen. And
yes.
So I know that and this was the same engine was running on either fuel. It was just the the processing of the fuel on the input side. He had it worked out where you could push a button on the dashboard to switch from the gaseous to the liquid fuels, and you would hardly hiccup as you were driving down the road and switched from one tank to the other. And
yes.
So I know that regular engines can run on hydrogen.
Yes.
And so with that assumption that the vehicles that are presently on the road right now could be fitted in the trunk with one of your generators of hydrogen running on you have some way to make electricity.
Yes.
How are you going to configure that to run this system? Do you think that is how long would it be for that particular application to do the engineering to come up with something that would work along those lines?
So, this is a very interesting question. We've been just recently approached by a company that came up with a hydrogen engine. And again, I understand with the regular engines there is only, I highly doubt that you can pump probably more than 50% hydrogen, because it might work probably an hour or two. Then the regular combustion engines are not designed for hydrogen. This is the problem, because the specific rate of combustion of hydrogen is much higher, and there is only so much you can pump. So, but as a mixture or as a hybrid, it will definitely work. So, to modify it, of course, there is a possibility with the current engines.
Yeah, you need to talk to Ty Robinson of Intergalactic Hydrogen, because he is expert on this subject, and it may be easier than what you're describing. It may not be that big of a hurdle.
You're absolutely right. But of course, nowadays, the interesting subject is also the fuel cells. So even though if the fuel cell, what is it, about 50% or 60% efficiency, and with our such over unity, it doesn't really matter what the efficiency of that fuel cell is, whether 50 or 60 or even 40%. So our hydrogen produces so much that it can basically cover all the missing parts. Mm-hmm. So again, we have no problem of going into integration with either fuel cell or any other combustion engine.
So this technology could become the generator technology for basically all energy needs of a larger sort. It would be hard to get efficient below a 1 kilowatt. You're probably talking about a kilowatt or larger, right?
Around that range, yes. Of course, we can make it smaller, but of course, the hydrogen reactor we have, of course, the test results show that we have equivalent of 221 kilowatts. So in order to fit on a regular car, our preliminary calculations show that we have to make it 331 times smaller of what we have right now. And again, these are only theoretical calculations. We have to make 331 times smaller to fit on a regular car.
Do you anticipate that scaling down like that will be difficult?
Of course, just like any other thing, actually, even the integration part, actually, when you're dealing with professionals and you have PhDs, and it's the reputation on the line, you know, some people think, actually, you might try to do it in a week or two, actually, but it's not real. So it might take a couple of months, could take up to 6 months, but of course it's doable. Mm-hmm. And the most important thing, you need to have that facility, you have to have all the necessary laboratory settings, so where you can do that magic. Of course it's doable, and you have to understand that's just another segment, because, you know, passenger cars, small cars, that's just another segment, you know, trucks and 18-wheel trucks, this above 10,000 pounds, that's another segment, heavy machinery, that's another segment. So we're talking about each segment, no matter what segment you choose, is a 10 or 20 or 50 billion dollar market. And there are at least 30 segments that we can talk about it, where our technology can be applied. So we're literally targeting that whole $7 trillion market of energy that is out there.
So your manufacturing facility would also be a research and development engineering facility to ask the question of how do we apply this technology to each of those 30 segments?
Yes, but of course we cannot just spread, because that would be an impossibility to work on those 30 segments simultaneously. So that's why when I talk about the consortium, to bring some, you know, these developed countries in, that would be a huge help. So instead of just, you know, one little company to develop all this stuff, we rather deal with big governments and have some kind of a deal with them, spread this technology by different segments.
I'm going to go political for a second, because a lot of our audience is of a frame of mind that governments have become very tyrannical and control-oriented rather than freedom-oriented, and there's a lot of corruption in modern governments today. Doesn't that make you a bit squeamish, the idea of working with governments?
Yes, it is, but now the second question, actually, what choice do they have? So again, you know, we are officially
rather than working with governments, you work with companies.
Well, companies are fine too, but you know, governments are in control, so they have the laws in their hands, so they can control whatever they want to. So again, we don't mind working with big companies as long as they will be in control of this technology, because if somebody invests billions of dollars, so they have to somehow manage to keep the proprietary stuff in their hands. But if you, I don't know, again, we don't mind working with anybody as long as it really makes sense. So what I mean by that, government, it could be a big entity, a big corporation, and
yeah, your technology could power a 747.
Absolutely.
It would take a lot of engineering.
Yeah, you know, we can literally replace it with nuclear power plants.
And that 747 would not require a fuel tank, basically.
No, of course, but it would require water, and we don't care what kind of water. It's a seawater, tap water, or river water.
What is the compared to gasoline or jet fuel as a fuel source in a jet, for example, mm-hmm. where 40% of the weight of a jet taking off is fuel. Mm-hmm. And I would think you'd be using much less water that's going to hydrogen to burn the hydrogen as fuel to create the same amount of fuel as the 40% of the weight of the 747 taking off.
You're absolutely right, because if you've noticed our latest press release, we're talking about conversion of 1 liter of water into 1 kilogram of hydrogen. And again, this is something that has never been done by anybody. And again, I understand it's mind-boggling to some people and most people, they wouldn't agree with that, but that's why we call the impossible becomes possible.
How much volume does 1 kilogram of hydrogen occupy?
Tell you, 1 kilogram of hydrogen is equal to 1 gallon of gasoline equals. So again, our cost is only 25 cents, and the regular gas is about, what is it, about $4.30 here in California at least. So our cost to produce the same equal amount of energy with 1 kilogram of hydrogen costs us 25 cents.
What I'm trying to get at is how much volume of fuel, water in this case, which is turning to hydrogen and oxygen, you're using hydrogen to burn in this process, how much water is required to, let's say, for example, if you were to convert a vehicle to run on water using this process, how many miles per gallon could you get using this process?
Okay, with the known science, actually, you would need about 9 liters of water to get 1 kilogram of hydrogen, with the science as we know it. With our technology, and it's a conversion of 1 liter of water into 1 kilogram of hydrogen. So you wouldn't need much. So you would probably need 5 or 10 liters of water, or let's say 3 gallons of water, for instance, in comparison to having 20 gallons, for instance. Again, this is just rough estimates.
So instead of 20 gallons of gasoline, you'd have 3 gallons of water.
Yeah, 3 or 4 gallons of water. That would be plenty enough for you to probably drive 300-400 miles. And again, the beauty of our technology that it is so powerful. Actually, we can literally even replace the nuclear power plants with their existing infrastructure. So basically, to keep the existing infrastructure and nuclear power plants and produce enough hydrogen, what is going to be a million times safer, and it's going to be thousands times cheaper than operating nuclear power plants. So that's how powerful this technology is. Again, we are literally declaring that the hydrogen era begun. So we're there already.
What about space travel?
Well, of course, this is something this is something out of my league. So I wouldn't be able. Of course, the technology can be can be applied. But of course, that would be just another segment, I would say. That would be
but still,
segment.
I mean, that's better than having to have these huge fuel tanks using rocket fuel to get to Mars. You could use a little more than 1/10 amount of fuel to get to the same distance using hydrogen.
You're absolutely
you can
right.
get thrust from hydrogen.
You're
obviously,
right.
I mean, didn't the space shuttle run on hydrogen?
Yes, it is. It's a hydrogen mixture, of course, and of course, definitely.
Yeah.
And of course, it's cheaper, and again, it's much cheaper. How much does a hydrogen cost nowadays? What is it about? Between $5 and $6 per 1 kilogram of hydrogen. Our cost to produce is 25 cents. Look how cheap it is.
And you're running on water rather than, of course, if you go and get a bottle of water from the grocery store, it costs as much as gasoline, if you think about it.
Yes, you're absolutely right. And yes, it is. And this is the beauty of our technology. And again, it hasn't been achieved by anybody. And again, this is what we have. Of course, we're welcoming anybody that is interested to test and see how, what the possibilities of test technology. You are very welcome to do that.
Yeah, locomotives, cargo ships could really benefit from this stuff.
Any segment that you choose, again, our technology can be applied. We can also use this technology as a hybrid for coal power plants, and at least to begin reducing 50% in emissions, for instance. So we can couple our technology with, a 500 megawatt power plant uses 250 tons of coal per hour. So think of it, how much particulate matter goes with an exhaust pipe. So if we can apply our technology to begin with as a hybrid, not to destroy the coal industry, but to go rather as a hybrid and reduce 50% on the emissions. In addition to that, there'll be lots of other savings because hydrogen is much cheaper because, again, it costs only about 25 cents equal to 1 gallon of gasoline. So, again, the possibilities are unlimited.
Yeah. How big is your team right now?
My team, we have about approximately either 10 or 12 guys, about 12 guys, if I'm not mistaken.
Working full-time?
Yes, almost full-time, almost. In addition, we also have a university, Eastern European university, with whom we have a contract. We signed a contract with them about 2.5 years ago. Yeah, they've been also a big help. on development of this technology.
Yeah, I was going to ask of this 10, 12 guys working almost full time on this, how many of those are on site there with you in California?
About 7 of them approximately. Either 6 or 7. I think 6 or 7, yeah.
Are you hiring?
Not at this stage. We don't have any funds yet. And, you know, most of the guys actually lately for last year and a half, actually, some of them are even on deferred payments. So this is the problem we have. The most interesting technology, and we're still trying to get, you know, funds for the last couple of months. And again, let's see how long it will continue.
I'd like to put this in very simplistic terms to show how easy this could be. All you would need to do to verify this, that anyone can understand and appreciate, would be to go to your facility, put an amp meter and a voltmeter on the energy supply that's powering your system, that is 400, 500 watts, and then measure the rate of gas flow on the output side. And that could be as simple as doing what I described, which is very barbaric, but it works.
You're absolutely right.
And it's quite accurate, you know, plus or minus 1 to 2%.
You're absolutely right.
That's going to give you easily enough evidence to show that this thing is indeed producing in the region of 400 times more energy out in the form of hydrogen than the electricity that was required to run the system on the front end.
You're absolutely right. You're absolutely right. Now the question is, we've had 3 press releases and we get lots of phone calls, and if somebody's interested in doing that, please, you're welcome to do that.
So what I just described, somebody who's a serious player could come and run that test and satisfy themselves that this is for real, and then start working with you.
Absolutely.
Whether it's giving you money or engineering or whatever it is that they want to do.
Absolutely. Absolutely. You're absolutely right.
What part of California are you at?
Los Angeles.
Do we want to go back to the earlier question about, you know, you've got 16 different physical and chemical processes. When I think of that, I think of rocket science. That's a lot of complication. There's a lot of systems going on, a lot of things going on at the same time. How difficult is this going to be for people to implement?
Well, it's not going to be really difficult. I can assure you of that. Again, I understand it took us 5 years to get to this point. Yes, we had real difficult times of achieving these results, real difficult times. But once it's complete, then it's complete. Then we have the explanation. We know how it's done, and it's we don't see any difficulties whatsoever in any form or shape.
Maybe I can help a little. This is Mike. You can have a lot of complex things going on in a single reaction.
Yes, you're absolutely right.
So the actual process could have been reduced to something fairly straightforward, but with a lot of complex, it's occurring in the blink of an eye.
Yes. You're absolutely right. And, we have lots of processes, and I'm sure there will be lots of work done by universities worldwide for probably the next 20 years, and hundreds of, if not thousands of dissertations on this subject alone. And
how are you going to do that if they can't get the secret sauce?
Well, the secret sauce, actually, one of our lead scientists is working on it right now, and we plan to publish at least a little bit so that people would understand what is it that we have. Because, we get lots of, skepticism. I understand that's normal. People are in total shock and disbelief, which is also normal. We understand that. But, of course, we have to give them a little bit of this so they understand what is it that is happening in our hydrogen reactor. So that's what we're trying to do right now, and that's what we're working on. And I understand, lots of people are struggling. They're struggling and trying to, unravel this phenomenon that we have in our hydrogen reactor. And that's why we're trying to help them to come up with something so that they understand, give them a little bit of theory and hypothesis so they understand what is it that is happening there.
There are 2 sciences that you've mentioned here that are, to me, satisfactory in terms of answering the question of where's the energy coming from. One is LENR. The other is cavitation. I know Mark LeClaire over at Nanospire is working on cavitation as an energy source.
Mm-hmm.
And they've made some really huge breakthroughs in that.
Mm-hmm.
And you have both going on in your system.
Yes.
And so that's why a few watts in is giving a lot of hydrogen production on the output side, is because in the process there's cavitation and LENR taking place, and that's where the energy is showing up.
Exactly, and it's not only that. We have lots of, as we were mentioning, we have lots of interesting processes that promote collective excitation of nucleons in the atoms of
Neutrons, you said?
No, nucleons.
How do you spell that?
Nucleons.
Nucleon.
Nucleon, yeah. Nucleons is in Russian, so I figured it's got to be the same.
Uh-huh. So the science on this is not brand new. There's a lot of engineering or legwork that's been done in the LENR field and in the cavitation field. So it's not like you're starting from zero in the scientific understanding of what's going on in your system.
I would call it, this is a new beginning completely, because if we believe our technology could really literally be the classic example of LENR. This is how much we believe, because we are in a position, we all know about the existence of continuous stream of particles that comes towards the Earth from Sun. So we are in a position to play with the particles. What I'm telling you right now, it has never been told. And you guys are the first to hear this, actually. We're in a position to play with those particles and manipulate, literally, any way we want to. We can target those particles. We can concentrate those particles. That has never been achieved by anybody.
Mm-hmm.
So, but I'm sure you understand the gravity of what I just said, because, again, to manipulate the particles, I'm talking about this existing continuous stream of particles that comes, from Sun towards the Earth.
Mm-hmm.
And there are neutral, positive, and negative particles. And, we're in position to manipulate. There are, people are building colliders to do these experiments. People are digging holes up to a mile deep, like the Russians did next to Russian Lake Baikal, to capture those particles. And again, you don't have to go any further than our hydrogen reactor. We have all those particles there. So this is the real breakthrough, besides the production of hydrogen, where this technology can be used. So this is just another breakthrough, perhaps I should say several breakthroughs that we have here. The particle manipulation, it has never been achieved by anybody in any form or shape. We can literally manipulate, little right, little left, back and forth, and this is the mind-boggling part in reality, not the hydrogen production itself. And so this is where we are. So when I can assure you that we're in fourth dimension. The rest of us, the rest of them, maybe I should say, they're in 3D. We're in 4D. So, and we believe that this technology, our methodology, can be used as a classical model for a low-energy nuclear reaction.
And the name of your company is Solar Hydrogen Trends. We didn't talk about the role, if any, that solar plays at this point. Is there a solar-dependent component in your system?
Well, of course, the solar, the reason we're mentioning solar is because, of course, what it also needs, actually, it only needs 500 watts of power to operate. So basically, that shouldn't be more than 2 panels of solar panels to start with. So that's the reason, actually, because otherwise it doesn't really need a solar panel. So the reason also we're saying solar is because of the stream of particles that comes from the sun that we are in control of. That so this is the part of the deal that the most of scientists aren't there yet. So
okay.
The stream of particles that come from the sun. It only requires 500 watts of power. So if somebody wants to use just 2 solar panels, actually, what is it? They're about between 200 to 250 watts each solar panel nowadays. So all you need is 2 solar panels, actually, to practically cover that huge amount of production of hydrogen.
Yeah. The
So,
downside of using that name is that the association that people have with solar is that it's sun dependent, and if the sun goes behind a cloud or at night, you don't have the sun, you're going to have a battery array, and that becomes a limiting factor.
if you can store the hydrogen in the daytime, you produce enough hydrogen, which of course you're producing almost, 400 times more, and if you can store it.
Right. I obviously understand the system, but I'm just saying that when you name the company Solar Hydrogen Trends, it's so much bigger than that. I think that's not really a good name for what you have.
Well, sun was because in the beginning also, this was about 2 years ago, we had photolysis that was involved in it. I'm sure you know what photolysis is.
Yeah.
But the efficiency of photolysis is about, the most you can reach with photolysis is nowadays, 10, 11, 12%. So, okay, maximum you can probably squeeze 15%. And again, so that was the beginning. That was about 2 years ago. But, with the final result, all it requires is 500 watts of power. So, solar, 2 solar panels would be plenty enough. You need that initial start anyway.
Not far from you is SRI, Stanford Research Institute, Mike McCougar and them.
Yes.
It's not necessarily, it's a 3 or 4 hour drive, I think, from LA to Menlo Park.
Yes.
Have you talked to them yet?
Yes, I did talk to Mike McCougar about 4 or 5 days ago, as a matter of fact.
How'd that go?
Interesting, as always, and I understand he's an expert in this field, and I told him the same thing, that, the most of the scientists are in 3D or in 4D, and it will take some time for others actually to catch up with us.
Mike, do you have any additional questions you want to ask?
I have many. There are many things I'd love to discuss with you, Jackob. But I'm also struggling with how much would be appropriate on an interview that would be public. It would seem that if you're able to produce hydrogen, and since I did a lot of research into some rather interesting mining technologies as well as energy, the two overlap, as you can imagine, because you came out of that background, right? And I'm sure you've probably studied some of David Hudson's work.
I'm not really familiar. David Hudson's, okay, I have no clue.
Fifth state of matter, OMI state, mono and diatomic bonding.
No, yeah, okay.
Very well worth looking into, because it's another overlap with LNR that's quite profound. And I can send you some information on that if you want. But another area that I've studied quite a lot is what I would consider inertial chemistry, where you're able to, and this is why I mentioned Hudson, regarding using frequency to cross the strong force barrier through inertia alone, which is one of the areas that I considered would maybe happening with LNR. Does that sound possible as to what's going on?
Well, as I was saying, actually, our technology, our methodology can be taken as a classical. We believe that this should be used as a classical, because, the cold fusion is there, they talk about it, but they don't have much explanation what is it that is happening.
No, this is primary understanding, primary manipulation of physics.
Yeah.
And of course, when you cross that barrier, then you also have an issue with patenting, because obviously you can't patent primary physics knowledge, but you can patent applications of that knowledge, right? So this could get very interesting, because I think begin to appreciate the enormity of what you've discovered here, and how it could be applied.
Because the beauty, actually, you have to understand that we can literally play with the subatomic particles. You have,
Right.
The beauty of this thing, we can manipulate. This is the secret sauce, actually, that is the major breakthrough. Because hydrogen, yes, hydrogen is there. We had lots of hydrogen. But of course, you have to have an explanation of, we can play and manipulate the subatomic particles with this continuous. Yeah.
You tweak the machine a little bit, or tweak the equipment, and that water could be converted to, say, oxygen.
Very well could be, yes. But so far, actually, we're turning that oxygen, we're turning that water into hydrogen because we don't have no oxygen. Literally, it's only 2.75%, so it's less than 3%.
So, so in your process, you're taking water and you're turning it into not hydrogen and oxygen, but almost 93% hydrogen.
Right. You're absolutely right. And again, we believe the nitrogen is some kind of a contaminant. It comes in as a contaminant. So somehow it gets, because our device does not produce nitrogen in any form or shape. So it must be some kind of a contaminant. And not to mention, we all know that 78% of air is consistent of nitrogen. So somehow it gets involved and it gets attached.
That was actually another question I had, was what was your equipment purely accessing water, or was it also accessing air on the input?
So it doesn't have any access. It's hermetically sealed. But again, you have to understand, there is only so much we can do on our part because, again, our device does not produce nitrogen in any form or shape. Somehow it finds the way to get in. Somehow. I don't know how.
Right. So again, it sort of agrees with some of the things I saw in the mining exploration in terms of, dare we use the word, transmutation, and how you achieve that without what I would consider now primitive approach of conventional nuclear theory. So yeah, this is really exciting to me. In terms of scalability, I wanted to ask a little bit more about that. Do you see being able to scale this down without too much difficulty, given the equipment you're using now and what you see that's market available?
Yes, we can do that. We did, for instance, we had a question from one of the investors said, can you fit this on a car? I said, of course, but, we did the calculations, and the calculation shows that we have to go, make it smaller 331 times. And again, the measurements, I don't know whether you have the measurements are 32-inch long, it's 14-inch wide, and it's 20.5 inches in height. So that's how, I don't know whether to say it big or small, because that's not a big amount. And look at the hydrogen production. It produces almost 3,000 cubic feet of hydrogen in 1 hour. That number is humongous.
A cigarette pack would be too big.
Well, I don't know. So these are the theoretical calculations. 331 times smaller. So there you go.
Okay. Well, okay. The automation that you're mentioning, that's one of my backgrounds.
Yes.
Custom automation and manufacturing processes. Do you see that the automation that you're requiring for this to be anything of new development, or are we talking typical engineering? Simply a matter of taking a principle and applying known hardware?
Well, I would say 50-50, because this is a new project that has never been developed by anybody. Of course, I would say 50-50. There will be some interesting stuff to add in addition what's in existence, but it's doable, and I believe that at least there are hundreds of companies will be able to achieve that. Even my scientists, they're saying actually, if we get the proper funding, we can do it ourselves.
Right.
So
yeah, because you can scale up slowly if you have the right customer to work with, where you're getting income from working with them, for instance.
Exactly. Again, this is that's why we call it an integration is an integral part to begin with, perhaps, because again, there are so many segments to work with. It's an impossibility to do all the stuff, simultaneously. It would be an interesting subject actually to work with to create some kind of joint ventures with big companies. And again, I should probably mention governments also, because again, to control such magnificent and interesting technology just for one or two, it's impossibility. Not one or two companies can achieve all these things. So we definitely need perhaps a government help, or several governments, or at least 5 or 10 big companies to be involved with this project.
Now, this is kind of a touchy subject, of course, because, I mean, you're talking to two people that have been bouncing around in this, what I would call a field of heretics for some time, which is talking about over unity. And there's a long history going back 150 years or so, where there's been clear breakthroughs that have never got anywhere. Do you see, I mean, when you start talking about governments, it's a touchy area because there does seem to be prior history where there has been the opportunity, and of course someone in government or private industry has squelched a technology. It's happened many times. This is, of course, given what's happening in the world today, something we don't want to see happen to you. And maybe there's some concern there to make sure that the strategy here is done in such a way that it cannot be shut down without causing negative repercussions like the crash you mentioned. One of my focuses over the last 4 or 5 years has been strategy in terms of getting this kind of thing out. And boy, there's 1,000 wrong ways to do it and a few right ways.
You're absolutely right, but one has to understand that again, with such project, and again, I hate to say this, but of course, God forbids actually if this technology actually ends up in the wrong hands. So one has to be very careful. Besides the spreading the technology on different segments, this has to be in the right hands to begin with.
Yeah, I mean, transition strategy is a very deep subject, isn't it? I mean, it's a chess game.
Yeah, absolutely, and again, this is out of my league personally, because it would definitely require a group of people to decide what would be the best choice and option to distribute this technology. Again, that's out of my league. I can clearly tell you that, even though I see the vision and exit. I personally envision actually that the technology couldn't be given to 30 or 40 big companies or governments, so that first of all, they're not going to harm one another. And look at the European continent. All of those countries actually, they're starved of energy.
Right. And, I like the fact you say it's out of your league, which probably makes you more qualified than most of the people that believe it's in their league. In other words, there's a lot of people that think they know how these kinds of things should be put out there. And in many cases, they don't know what they're talking about.
Yeah, and personally, I envision, again, the exit strategy is to have many countries to be involved, so to help one another instead of harming one another. Because if this technology ends up in one or two hands, then the possibility of shutting this down, the percentage is enormous, high. But if this technology ends up in 15, 20 hands, and they have the equal amount of rights and shares, the possibility of distributing and making even more money will be unlimited. So this is how I see it. So they can make more money and keep themselves happy, and besides the economy, look at the ecological point of view.
Yes, huge.
Where this technology can be used.
And of course, I mean, if you look at the kind of energy output, in most places you could pull as much hydrogen right out of the air in the water that's in the air as you want. You don't necessarily have to have a water source.
Yeah, if you're located somewhere that the humidity is high, about at least 40% or 50%, you have no problem of doing that. But if you're located somewhere in the desert with humidity of 4 to 5 or 6%, again, then you're going to have difficulties of doing that. Of course, you can do that, but of course it might take you a bigger equipment and much more time to do that.
Right. It comes down to equipment and power, basically.
The beauty of this technology actually is also it can be literally attached to wind power mills, for instance. It can be also attached to solar panels, on peak hours, because, solar panels don't work at the nighttime, including the hydropower stations. They work 90%, 99% of the production is the daytime. At nighttime, they're shutting it down. And of course, if such technology can be applied with hydropower plants and to increase the output 50 times or 100 times.
Yeah, you're being very generous to tie this to windmills and solar, when in reality what you have makes those obsolete.
You're absolutely right. But again, not to kill those industries. The reason I'm just saying it actually, why not make some kind of a hybrid system with those wind power mills, for instance, including solar panels, for instance. If somebody wants to go double it or, go 10 times more or 20 times more, The sky is the limit, you know.
Yeah, this is collaborative business instead of competitive, Sterling. So, which is really what's needed. You know, it's not about putting people out of business, as we've discussed.
Exactly. So is with the coal industry. Look, you know, the emission controls are so strict nowadays. You know, by 2016 or 17, you know, some people are saying 50% of all coal industry, the power plants, will be out of business because they have to either modify, retrofit, and comply with the new standards. And I think this is a perfect timing to bring this hydrogen and you know, make hybrids, at least with, you know, 50% reduction on coal consumption, including 50%.
Well, you use their infrastructure. They've got the power plant built, and you just plug this stuff in instead of the coal as a fuel source. You use this as a fuel source.
Well, you can use a little bit of coal, of course, and of course, you know, the only modification would require is the combustion part, is the boilers, for instance. Not much would really, you know, you wouldn't take much.
Well, you can use the carbon in the coal over and over again. So you can keep injecting, you know, because let's face it, any fossil fuel like coal or any gasoline is essentially a carrier for hydrogen, and it's the hydrogen that's being used to create energy. And so you can recirculate the component that isn't the hydrogen.
Well, again, there's so much possibilities. It's really unbelievable, and it's mind-boggling where this technology can be applied. And again, it can be used for outdoor generators. And again, like I was saying, no matter which segment you choose, we're talking about $20 or $50 billion market alone. You know, it can be used, applied in boats, you know, above 40 feet. Between, you know, the largest interesting part is between 40 to 100 or 120 feet boats, for instance. The majority of boats. So we're talking about savings of billions of dollars right there.
Well, the freighters, I heard an alarming statistic. I still don't know if it's true, but it seems to be, which is one freighter created as much harmful pollution as 50 million cars. When I first heard that, I didn't believe it, but heard it from quite a few sources.
They are very inefficient. They pollute tremendously.
Yeah, and if we make, for instance, a comparison to natural gas, what is it? 1,000 cubic feet in the United States costs between $5 and $6, if I'm not mistaken. And production of our hydrogen, in comparison to natural gas, it's only 65 cents. So we're talking about practically 10 times cheaper than natural gas.
So how, in terms of appliances, we've got a lot of appliances in our house that run on natural gas, our stove, our dryer. Will they run on hydrogen just as well, or do you have to modify them to do that?
They can definitely run, not to mention hydrogen you can pump with the same infrastructure of gas pipes. And I believe, if I'm not mistaken, the most you can use is about 28% mixture with natural gas. So again, you can use the same infrastructure and pump this hydrogen, which again, specific heat of combustion is 3 to 4 times more potent than any other known fossil fuel.
So one obvious application of this technology, an early low-hanging fruit, would be natural gas companies, where you could put this generator at their source and mix the natural gas with hydrogen.
You're absolutely right. And the consumer, of course, would be using less, because hydrogen, as I was saying, it's between 3 to 4 times more potent than natural gas. So that means you would be using, of course, little less of that gas mass than previously. So, of course, there will be lots of savings. There will be lots of savings.
And as I understand it, when you switch from, say, natural gas to propane, all you're doing is changing the orifice size of the injector. Very, very simple conversion. And it may be the same in hydrogen, where all it takes is a small conversion in the unit, and now you're doing a much higher percentage of hydrogen. So
you're absolutely right. You're absolutely right. And again, the same infrastructure can be used, and the sky's the limit. So anything you can think of, our technology can be applied. When we say it's a new commodity on a market, it is, in fact.
I'm having a hard time conceiving of it powering my laptop and my cell phone.
Well, that's called a fuel cell. Could scale this principle down to where you could theoretically power a fuel cell with it, right, Jackob?
Yes, of course. You can have a little device, for instance, in your backyard, and you can generate hydrogen as much as possible. Again, our job is to generate the hydrogen with our hydrogen reactor. And again, fuel cell is to deal with a fuel cell, that would be an integration. That's not our expertise, even though we understand how it works. But of course, that would be bringing two technologies together and coupling them together.
One of thousands of applications and collaborative technologies. I'm blown away.
Yeah, and for instance, one of the easiest segments I personally think actually could be used, for instance, for farms. There are 300,000 farms in the United States alone, and in addition to that, grocery stores. There are 37 or 38,000 supermarkets in the United States that use in average 400 kilowatts per hour. So this technology can be applied for grocery stores or farms, and in average poultry farm, big poultry farms, they pay $250,000 for utility bills on a monthly basis, between $250,000 to $300,000. So just by cutting that middleman, the utility company, we can install our units there and generate the same amount of electricity, and by providing at least, give the consumer 50% reduction on the consumption of electricity. So without paying that middleman, the broker, the utility companies.
Well, any other questions I have probably wouldn't be appropriate for audience, but I'm very, very impressed.
Yeah, it is impressive actually. We were shocked ourselves when we had the test results, because quite honestly, we weren't expecting such huge amounts of hydrogen. And again, to make 1,318 liters of hydrogen in 1 minute, I think that's pretty impressive.
And for the oxygen to disappear in the process.
Absolutely. So that's the question. Where does the oxygen go? So that's the question.
It's more impressive that you're making the oxygen disappear than it is that you're making the hydrogen.
And also, in addition to that, just by using probably a little less than 2 gallons of water. That's even more interesting, because again, we should have used lots of water, but it's been, the records indicate that we've used a little less than 2 gallons of water.
Fascinating stuff. Well, I really appreciate being able to do this interview. It's been a lot of fun. Anything else that we want to cover before we close?
I appreciate. Thank you. So the only thing I should probably say again, the technology is so powerful, is again, like, where do we start? Because we can literally turn the ocean into ocean of hydrogen, and we have 2 oceans, the Atlantic and the Pacific. So where do we start?
Yeah, your website domain name is?
solarhydrogentrends.com.
solarhydrogentrends.com. And they can contact you through that?
Yes.
Okay.
Yes.
Very good. Well, thank you for your time, and thanks, Mike, for your involvement. It's been fun.
Thank you, gentlemen.
Thank you.
Take care.
You've been listening to Free Energy Now, brought to you by PES, Pure Energy Systems. You may access past archives and upcoming show info at freeenergynow.net and join us for our daily news at freeenergynews.com. We invite you to see our directory of energy technologies at peswiki.com. That's peswiki.com. PES, the Pure Energy Systems Information Network.
You also have some cold fusion going on, I understand.
Well, I would be really careful using the word cold fusion. Is for scientists to determine what is it exactly, but what I can assure you is that we have a real low-energy nuclear reaction.
When we talk about LENR, we're not talking about a low amount of output, but that a low amount of energy is required to get it to take place in the first place.
Well, the reason we're saying it's low energy actually, because of course the temperature, you have to pay attention to the temperature, that what is happening. If we're talking about 50 or 60 centigrade, how would you else describe it if it's not low energy nuclear reaction. If it's only, let's say, 60 centigrade, and you have fission and fusion together combined.
Wow.
Yeah, if somebody can tell me it's not a low energy nuclear reaction, then I would like to know what it is.
Are you getting radioactive elements or radiation coming off of it?
Not really, no.
Now, do you have a diagram somewhere on your website that kind of shows a forced view of these different systems and how they interact?
We don't have that because we still consider it proprietary, and that's why we're not disclosing much the steps of all those processes that take place simultaneously. That's why we call it a symphony, and our latest hydrogen reactor, we call it Symphony 7A, because we have 6 other previous models that we've been working for the last 5 years.
And so your first prototype was built 5
Free energy now.
Imagine a world in which each home has its own power generator that obtains its energy in such a way that no fuel has to be added. Imagine every vehicle being able to run without ever stopping for fuel. Imagine each appliance having its own power source that never has to be recharged. That is the world of the future. Join with us now as we track our progress towards such a world.
Welcome to the show. I'm your host, Sterling Allan. You can find us online at freeenergynow.net, where you can find a list of past guests and download those interviews. Today, April 25th, 2014, we are joined by Jackob Aganyan, who is with Solar Hydrogen Trends, a company in California that has an amazing super-duper hydrogen production technology using solar and many other modalities. We're going to find out what it is, how it works, and where they're at in the process of rolling this thing out, if they're licensing and all those kinds of business questions along with the technical questions. Jackob, welcome to the show.
Yes, hello. And just a little correction, my last name is Aganyan.
Ah. And you're getting 400 times that out?
Yes, whatever the results are, it's equivalent of 221 kilowatts hour, which is, I believe, it's about either 440 or 450 times more, approximately.
Didn't you recently do some third-party testing?
Yes, we had a third-party testing. It's a reputable company here in California, and it's a nationwide company that does these tests for big companies, for big oil companies. So they do tests for, big companies.
Uh-huh.
All the oil companies that you can name.
Were they measuring the entire system, the Symphony 7?
Well, their job was to basically, take the flow rate of the gas mass, and including to that, they were taking quantitative and qualitative analysis. So there were also a second company involved, which is also one of the most reputable companies in the world. It's the laboratory that does the qualitative and qualitative analysis. There's 2 companies actually involved.
So they're basically ascertaining the quality of the hydrogen gas coming out on the output side, right?
Yes, but also in addition to that, since we're talking about qualitative and quantitative, also the other compositions, nitrogen, for instance, oxygen. So.
But that's not really an energy equation in terms of input versus output and energy efficiency test.
You're right.
Years ago.
Yes, exactly.
You called that one?
That was exactly. That was product 1. Then the second model came up, the third, the fourth, and it was really interesting time when we knew we're on something. But the idea of hydrogen, actually, we were working on something else. This is an accidental discovery, and we've been working and developing a method to recover and extract precious metals from Mother Nature. So this is an accidental discovery, And again, we were using hydrometallurgical and pyrometallurgical methods when we came across with this huge amounts of production of hydrogen. And we didn't know what it was in the beginning, of course. So when we knew that we have this huge amounts of hydrogen, then that was a very interesting subject to us, and we moved from precious metals to hydrogen.
How long ago was that switch?
That was about 5-6 years ago.
And that's when Symphony 1 came out?
Yes. Well, we wouldn't call it Symphony 5 because there was only a few processes that we were combining together. So that would have been a simple electrolysis with perhaps with heat and additional cavitation processes included. So that would probably include either 2 or 3 methods combined together. So it took us some time to elevate and bring all these additional methods and processes, to be added, which at the end we had 16 processes combined together. And of course, the most important fact that we're only using the input of energy is only 500 watts of energy. Yes.
You don't expect an American to know that, do you?
Well, I'm an Armenian descent, so I have an Armenian last name. Again, Aganov is just, I came up with that last name so that not a lot of people would try to get in touch with me, especially on Skype. So I have to keep it kind of secret.
Well, now it's not secret anymore. And we also have Mike Waters on the line with us. He's the current president of the New Energy Systems Trust, or NEST. Website is energynest.org. And he has a lot of interest in this technology as well, and we'll be chiming in with additional questions that I might overlook, or to dig deeper in the how does this thing work series of questions. So, Jackob, tell us about this technology. There's like 16 different modalities or mechanism at play in getting like a 400 to 1 efficiency scenario.
Yes. So what we have is 16 physical and chemical processes that occur simultaneously within the reactor. And I can name few. We have electrolysis, we have oxidation, catalysis, we have ionization, we have infrasound, sound, ultrasound, hypersound, we have hydrodynamic cavitation, we have electromagnetic field, we have a shock wave, turbulence, I can name few, so we have lots of it.